right, so let's take a look at another Thevenin equivalent example. So here's the circuit we want to do. And we're asked to find I using Thevenin's theorem. So you see I and our A and B are kind of right in the middle of the circuit. But that's okay. Location doesn't matter. It can still be considered our load. So 12 ohms for this one is our load versus the last example where it was out there on the end and it was pretty easy to tell. This one's a little bit more challenging. So let's first look at finding our R Thevenin. So same thing applies. We want to deactivate our sources and cut off our load. And I'm drawing a source anyway after just saying I want to deactivate it. If I deactivate that 50 volt source, I get just a line there. I am cutting off the load. Cut. A, B. Deactivating the 30 volt source. And I have this 40 ohms here. So I want the resistance is seen by the 12 ohm 12 ohm resistor. So between A and B there, what resistance is seen? Well, the 10 and the 40 are both sharing the same two nodes, meaning they're in parallel. So our R Thevenin is 10 in parallel with 40, or 10 times 40 divided by 10 plus 40, or 8 ohms. So we have our R Thevenin. Now we need to find our V Thevenin, or our V open circuit. So we want to open that location and find the voltage there. So this is to find V Thevenin, or V open circuit. It means the same thing. So now our sources are back, 50 volts, 10 ohms. That's where we want to find our voltage. 30 volts, 40 ohms, and we're looking for V open circuit, or V Thevenin, right here. Now don't fall into the trap of saying that V Thevenin is equal to 30. It's not, right? We have 30 volts from this node to this node. Well, that's not the same two nodes. Those are different nodes. So it is not 30 volts. You can't simply say 30 volts. There's a few different ways we can look at this, though. Trying to decide which one I want to do here on my page. Let's write a KVL loop around here. And I'm just going to call this V40. So it's the voltage across my 40 ohm resistor. So if I do KVL, I have minus 30 minus V Thevenin plus V40 equals 0, or V Thevenin equals 30 minus, switch those around, right? V40 minus 30, algebra error. V40 minus 30. So I need my V40. How can I find that? Well, V40 is the voltage from here to here. So that's the voltage from this node down to here. So I can call this very top node up here V40 and do nodal. I have V40 minus 50 over 10 I don't do anything here. This is an open circuit, so in Ohm's law, V equals IR, open circuit, current is 0. Don't need to worry about that voltage. 40 minus 0 over, V40 minus 0 over 40 equals 0. If I solve that, I get V40 equals 40. How ironic. That then means that my V Thevenin is 40 minus 30, or 10 volts. So how do we draw this one? Well, the same exact way. V Thevenin, or 10 volts, R Thevenin, or 8 ohms. I don't need that line, but that's okay. Goes to the load. which is 12 ohms. That's location AB. So this circuit provides the exact same thing to this load as this circuit provides to that load. But that's a lot easier to work with, a lot easier to see than this one. So Thevenin has a really important place in circuits, especially as you go along, for those of you who will take electronics and the power courses and continue with circuits.